Conventional automobiles burn gasoline in an internal combustion engine and convert that energy into motion. But first a spark is needed to ignite the fuel mixture. This demonstration shows how a 12-volt battery generates the high voltage required to create such a discharge. The heart of a car's ignition system is its ignition coil. This coil is a kind of transformer, a device that transfers voltage from one circuit to another, either as a lower voltage, or in the case of the ignition coil, as a higher voltage. It does this by creating a changing magnetic field that induces a current in a conductor exposed to that field, a principle known as electromagnetic induction. Like other transformers, an ignition coil consists in part of two coils of wire, both wrapped around the same iron core. The inner or secondary coil has far more turns of wire than the primary or outer coil, making this a step-up transformer that will convert the battery's 12 volts into some 40,000 volts of electricity. First, we will close the knife switch to create a circuit that includes the battery and the induction coil. Although electrons move from negative to positive, the convention is to think of electrical current as moving from positive to negative, so that's how we'll show it here. As current flows to the primary coil, a magnetic field gradually builds up around it, as well as around the secondary coil housed inside. If we open the knife switch to stop the current, the magnetic field suddenly collapses. Due to the principle of electromagnetic induction, this rapid change induces a surge of current in the secondary coil, which streams out and jumps the spark gap in the circuit. There is something else happening when the knife switch is opened. Let's watch again. This time, keep your eyes on the capacitor, two plates separated by an insulator. When the knife switch opens and the field around the coil collapses, the collapsing field around the primary coil induces a surge of current, called back EMF, in the primary coil. This unwanted surge of electricity travels back toward the switch. The job of the capacitor, called a condenser in auto-ignition systems, is to safely absorb the back EMF and prevent the surge from reaching the switch and creating a damaging spark across those points.